P-value is defined as follows. Assuming the null hypothesis is true, the p-value is the probability of getting a value of the observed statistic or more extreme. Let's think about what that means. Find an observed statistic out in the world. As we simulate, we create a null distribution. That null distribution is the set of sample statistics that we expect to get if the null hypothesis is true. So this is the null distribution. It's the distribution of sample statistics we expect to get if the null hypothesis is true. Notice that means we are assuming the null hypothesis is true when we build this null distribution. This null distribution is centered at the hypothesized value of the parameter from your null hypothesis. So it'll either be centered at the pi from your null hypothesis, or it will be centered at the mu from your null hypothesis. About half the expected sample statistics will be above it, and about half will be below it. So we got an observed statistic. We simulated to create this null distribution. And now the third step is finding strength of evidence. So far in the course, what we've said is we've kind of been a little wishy-washy about it. We've said if your statistic turns out to be kind of up here in this area where there are not many dots or there are no dots, or if your sample statistic kind of comes out down here in this area where there are no sample statistics or just a couple dots. Then if it comes out in one of those tails, the left tail or the right tail, if that's where your observed statistic was, then you conclude that you have a lot of evidence against the null hypothesis. You have a lot of support for the alternative hypothesis. If your observed statistic came out here in the area where you see a lot of expected, normal, and usual sorts of statistics, then you would say that you think the null hypothesis is plausible. What we're going to do is we're going to add what's called a p-value to this, where we actually put a numerical mathematical value with our conclusion, with our strength of evidence. Okay, so again, let me read this one more time and kind of put that together with what we've learned. It says, assuming the null hypothesis is true, the p-value is the probability of getting our observed statistic or more extreme. So it's saying if the null hypothesis is true, then this distribution shows you what sample statistics should look like. You then locate your sample statistic on here. The p-value is the proportion of sample statistics that are like your sample statistic or more extreme. Basically, you will count the dots that are like your sample statistic or more extreme, and then divide by the total number of dots. So the p-value, you count the dots that are like your sample statistic or more extreme and divide by the total number of dots. Again, the dots here are in your distribution, the dots. But remember, the dots represent the sample statistics we expect to get if null hypothesis is true. So you're counting samples that would be like yours or more extreme out of the total. It's giving you like a probability of getting a sample like yours if the null hypothesis were true.